Hi everybody, welcome to CompuScholar's Professional Development webinar for March in 2021. Today we're going to be talking about the software industry job outlook and desired skills. And this is actually an update of a similar presentation I first made back in December of 2017. So I thought it would be fun to kind of check out the numbers and see how things have changed in the last 4 years. My name is Chris Hust. I'm the president of CompuScholar. I spent quite a few years as a software engineer and also had the opportunity to own my own consulting firm, so I've interviewed many candidates for jobs, and that's the perspective that I bring into the curriculum space. I'm the co-author of all of CompuScholar's courses, and I'm always happy to answer your questions at chris.hust@compuscholar.com. So today we're going to start and take a look at the job outlook, so we'll look at unemployment rates and salaries and that sort of thing for software engineers. And then we'll quickly touch base on the in-demand programming languages. So what's new and hot in 2021, and what are the major programming languages that everybody wants you to know as you go looking for jobs. We'll touch slightly on some desirable interpersonal skills that are always useful for software engineers, and then wrap up with the review of your CTE goals for your high school program and make some suggestions that may be a little bit different than what you're used to hearing. All right, job statistics. There's a lot of great information out there at the Bureau of Labor Statistics and other websites. So all this information is out there online in some form or fashion. So for software engineers, back in 2017, there was actually a 24% growth outlook for the upcoming decade. And so how has that changed? Well, we still have a 22% growth for software engineers over the next 10 years. So software engineers remains one of the hottest jobs in terms of growth and expansion here in the United States. Now, 4 years ago, the unemployment rate national average was about 4.5%. And today, the average unemployment rate has bumped up to about 6.2%, and that's largely due to COVID reasons. So that's the national average across all professions. For software engineers, the unemployment rate is actually really good. Depending on where you look, it's somewhere between 1% and 3%. And that actually hasn't changed in the last 4 years. So unemployment rate was very, very low back in 2017, and it's still very, very low today. So software engineers are obviously very capable of working remotely and operating out of virtual offices, so the pandemic has not really impacted the unemployment rate for software engineers. So what's happening to the salaries for software engineers? Well, back in 2017, the entry-level salary for a software engineer, so this is someone that had a 4-year computer science degree coming out of college, was somewhere between $60,000 and $80,000. And today that number has moved kind of to the high side of that range, so the average starting salary for a software engineer is generally around $76,000, which is pretty sweet. If you compare that to the entry-level salary for all other degrees, so every other type of degree that's out there, 4 years ago, the average starting salary was $41,000, and that's actually risen pretty nicely to $51,000. So even though that average salary is going up for all degrees, you can see there's still about a $25,000 difference between software engineers and other types of degrees in terms of that entry-level salary, that starting salary. If you want to know what the average salary is for a software engineer, so after somebody's been working for a few years and they've got their feet under them in the market and they've got some job experience, the average salary used to be about $100,000 a few years ago, and that has risen up to $107,000 today. So the average salary for software engineers continues to creep up, just like the base level salary. So as you can see, software engineers are certainly still in very, very high demand here in the United States. So if your kids are worried about whether or not there will be jobs out there for them when they graduate, you can certainly reassure them that the job market is great and has been holding steady for many years and is projected to hold steady for many years to come. All right, let's touch base on some in-demand programming languages. And so when you search online for the most popular programming languages, you will rapidly find that everybody has a different list and they rank them differently according to a variety of criteria. Some folks will look at job applications and job requirements to see what employers want. Other people will look at some public code bases to see what people are coding in. So there's a lot of ways to rank these things. And some people will include what I would call specialty languages in and amongst the general purpose programming languages. So I just kind of split them apart, and these are not ranked in any order. But your general purpose programming languages, most popular, most people will agree, are things like Python, JavaScript, Java, C Sharp, C and C++, and PHP. And of course, there's a few others as well. The slide was only so long, but there are plenty of good languages out there. In terms of specialty, so languages that you're going to generally use for a specific purpose, obviously HTML and CSS is king of the heap for web pages. You'll want to know SQL to work with your databases. And then the last three are actually relatively new, and they didn't appear on the presentation at all 4 years ago. So Google Go is a new systems programming language by Google. R is a language that a lot of data scientists will use to crunch and analyze big data numbers. And then Kotlin is a language based on Java that is becoming more and more popular for Android apps. So there's always new specialty languages that crop up and come and go. And the kind of the big picture message here is that you want your software engineers to be multilingual. So you want them to be able to comfortably code in multiple languages, because they're going to have to do that as part of their day jobs. So with that in mind, there's a question I'm often asked by parents and teachers. That is, what language should we pick in order to really prepare my middle or high school student for the job market? I want to make sure my student is successful when they graduate high school. I want to make sure they know the right languages so that they're going to be competitive. And the answer really is it doesn't matter at all. These are high school kids, these are middle school kids, and at this point we're not trying to prepare them for the job market. We're trying to get them interested in computer science. We're trying to make this something that's fun and interesting for them. So as long as the language they start with is presented in a manner that is successful, so it's a fun, engaging experience for the students, they're going to pick up those skills and they're going to be able to learn similar languages very, very quickly. So that's why when people start to get a little bit wound up about should we teach Java in high school, should it be C Sharp, should it be Python, it really doesn't matter. It depends on what you're comfortable teaching and the type of curriculum you can find that's going to successfully pitch that language to the students. So in terms of personal skills, really nothing has changed here in the last 4 years. So in my own observation, being in the industry a long time, what kinds of things are going to govern your long-term success as a software engineer? Joel Splowski has a very popular blog on software engineering and hiring, and his short answer is be smart and get things done. And so that's what he's looking for in a job interview. So he's not necessarily looking for certifications or long alphabet soup worth of acronyms and things that you know, but he's trying to figure out, are you smart and can you get things done in the job interview? A longer answer might put some emphasis on communication skills. So in my own experience, software engineers need to be able to write. So they need to write documentation, whether it's design documents, requirements documents. They need to be able to communicate clearly and articulately to their teammates. And so as a software engineer, you do need to have some good communication skills. And of course, software engineers all work in teams these days for the most part. So you're not going to be off by yourself doing your own thing. You need to work with your team on a daily basis. And so those interpersonal skills are critical, just like they are in any other sorts of job. And then the last thing I'll mention is that it's really advantageous if you're able as an employee to understand the big picture of what your company wants you to do. So you can easily find software engineers that you can hand them a requirements and design document and they'll crank out the code. But it's rarer and more valuable to find software engineers that are able to write the design and requirements documents based on their understanding of what the customer needs and what the company wants. And so being able to bring that kind of architectural expertise, that understanding of the big picture to the table as part of your skill set is a great way to work for a very long time in the software industry. Okay, and I just wanted to wrap up with a few thoughts about the goals of computer science courses in a CTE program. So I suspect that many of you will find some of these goals pretty familiar. You're probably under some pressure to help prepare your students for the job market, graduate some many Java engineers out of high school. You're probably motivated to get your students certified by industry exams in some form or fashion, and you probably have requirements to teach them a lot of soft skills as well. So from our perspective, none of these goals are really super important for high school kids. So this is not necessarily the best use of their time. And why is that? So because computer science is often in the CTE department, the focus is on job seeking. And so we keep running into situations where we're talking with schools and districts and they're trying to figure out how to get their kids job ready out of high school. And really, for a software engineering job, for all these great salaries and low unemployment rates I was talking about, you're not going to look at the high school experience. So an employer wants a 4-year degree out of college, so a Bachelor of Science in Computer Science or something similar. Your employers are not looking at your high school experience. They're not looking at any fancy certifications you may have gotten in high school. So it's all about what you've done in college. Did you have any job experience, some internships, and that sort of thing in college? And can you present yourself as somebody that is smart and gets things done in the job interview? So those are things that are the most important when it comes to actually getting that first job. And so if our focus in high school is not necessarily on job prep, what should it be? From our perspective, your goal in high school and middle school is to introduce students to computer science, see if they have a knack for it, see if this is something that is interesting to them, and encourage them to pursue that computer science degree in college. Again, that 4-year degree is kind of the foundational prerequisite for most software engineering jobs and all that great job security. And so as a CTE course in high school, we're not necessarily focused on job readiness, but we should be focused on interest and aptitude and career path. So we encourage districts whenever we can to offer a variety of courses that are fun, that are introductory level, and that students can schedule at any time. We do run into situations quite often where the district or the state has mandated certain pathways where kids have to decide what they want to do with the rest of their life in 9th or 10th grade, and then take this long sequence of Java 1, Java 2, Java 3, and then some sort of capstone or practicum course. And those pathways are really very, very difficult for students to manage. They're not flexible at all, and they can be quite discouraging to get through to those later stages. By contrast, where you're able to, if you're able to offer some fun introductory courses, whether it's web design, video game design, programming in a number of different languages, you can give your students that breadth of experience with different programming languages, and you really just need to find those 1 or 2 courses that's the hook for the students that makes the light bulb go on, that encourages them to pursue that degree track in college. So we recognize that a lot of times you're up against requirements at the district or state level that you can't budge, but we do like to at least throw this thought out there when we can, that your goals here in high school are not necessarily the certification, the job prep skills that you may be used to working towards, but more a matter of just identifying and funneling the kids that have this aptitude into that degree track in college. And we'd like to do that again just by making these classes easy for anybody to take, whether they're a senior or a freshman. They should be able to pick up a computer science class and try their hand at coding and see if that's something that they would like to do. As always, we appreciate your time today. Always happy to answer questions by phone or by email through our website, or you can contact me directly. Have a great day.